Just
There
relax.
it goes. And we're live. Greetings, fellow nerds. Welcome to another exciting episode of Between Two Nerds, where we talk with prominent guests about all aspects of the networking industry, from protocols old and new, to industry trends and drivers, to upcoming technologies, and as always, things you should know to further your career. Mr. Tansura, good to see you.
Good to see you too, Jeff.
We've
It's been a
we've
month.
sort of been negligent of our. I've been negligent of the show for a while. It's nice to be back.
We are going to improve. We promise.
Yeah. We always say that, don't we? We're going to do better in the future, but maybe someday we will.
Absolutely.
So what's been? You've been to an IETF, I guess, since the last time we've had a show, haven't you?
No, actually, I couldn't go because of personal engagement.
Oh, okay. I thought you had gone to that.
But it's been busy. A lot of IPv6 stuff that's not
Okay.
working that should be working. Just when you move from one other's family to another.
IPv6. Are people still doing that?
Some do.
Someday it'll be there.
Yeah.
Hey, well, today we're going to be talking about infrastructure as code, and specifically one tool for IAAC. I can't say that well, which is Terraform. And we've got three terrific guests on today. Our friends Bill Wester, Raj Subra. There you go. Thank you so much for bailing me out on that. And Chris Margette. And we're, these are all, I guess before the show started, we were talking about this. They're all fellow Apstra people that I work with and have done quite a bit of development around Terraform in the context of Apstra. And you'll see some of that demonstrated today. But the real context of the show doesn't really matter whether you use Apstra or not. That's just, we're sort of using that as a demo vehicle. It's really about Terraform and what Terraform can do for you. And so I'll just start that out. I have a feeling that the guests or the audience of the show probably would not be tuning in if they didn't know what Terraform was, but we should start there. So heck is Terraform.
Take it.
Awesome. Hey, everybody. My name's Chris Margette. I work for Juniper, as Jeff mentioned. My background is in systems and network admin. Being at a vendor is new for me. I've been customer side for decades. And I look after automation tools at Juniper around the data center, and Terraform in particular. And I guess I should give Bill and Raj a chance to introduce themselves.
Sure.
Bill?
Yeah, Bill Wester here. I've been doing data center networks for forever, and part of the Apstra team. And I got super excited about Terraform, I don't know, a couple of years ago when Chris started talking about it, and I realized how synergistic it was with some of the things we were doing with Apstra. And so super great tool. I'd heard of it before and used it before at F5. But we really dived a lot deeper into it here. So I think it's just awfully powerful. And we'll look forward to talking about it. Raj?
Yep. Hey, folks, I'm Raj. I've been basically a software engineer all my life now, my professional life. And then I've been working with like infrastructure automation for the last, I want to say, 10 to 15 years. So when I joined Juniper, I started doing integrations with Apstra. And when Chris started the Terraform project, I hopped on because it's something new and awesome. And that's basically been it. Like I continue to work on infrastructure automation, mostly around Apstra. That's it, Chris.
Cool. So we should probably talk about network automation in general to begin, right? Because I think there's a network-centric audience for this show. And when network people talk about automation, even if they're in an infrastructure as code sort of mindset, it's usually not Terraform, right? Most network automation stuff that you're going to see is either homegrown stuff with Jinja templates and pushing, assembling templates and pushing them with Ansible. or some either vendor or third-party tools that do real similar config-based automation, right? It's all templates. As network folks, we're real good at dealing with big blobs of text and treating them like Mad Libs and putting the right variables in the right spots and deploying them to the switches that need those features. And that's not really what Terraform does. Within Juniper, we do have some Terraform support for Junos, so it's Terraform support for text, because some people just really want to do it. But in my view, that's really square pegs and round holes kind of a situation. So the upshot of all that is pure network people probably haven't worked with Terraform, and my experience talking to customers about it bears that out. If we can find the DevOps people, the people that are looking after cloud stuff, they know exactly what we're talking about, and it's a great fit. But it is unfamiliar and scary to pure network folks who are used to thinking about configuring their network with when their brain immediately goes to rendering text as the definition of automation.
And we found that a lot. We've actually been doing a series on network automation here, and we see that over and over. Where people that are familiar with cloud operations and such and DevOps type people are pretty comfortable with automation tools. And old guys like me, the CLI jockeys that are a little befuddled by it sometimes.
The work that those cloud kids are doing is kind of amazing, right? Like, a modern SRE person, DevOps person is looking after the operating system. They're looking after the virtual machine base images. They're like database admins. They're making databases. They're doing network work. They're doing security policy. They're doing load balancers, like up and down the stack, storage, right? And like everything I just named might have been a different team in a traditional enterprise, a decade or more ago. So the breadth of stuff that they're responsible for is amazing to from the old timer perspective, and I think it's just possible because the tools have all evolved and gotten so much better, and the automation's gotten better, and it makes it possible for those folks to just take responsibility for so many different parts of the stack. And that's
from
yeah. And it's progressed on-prem too, right? I mean, getting a new server doesn't mean buying a server now. It means instantiating a VM, right? And setting up the storage for it is just something you do, within the vCenter console.
And that probably gets to where, if you look at just general classifications of automation tools, that you really got to where Terraform fits in. I mean, you've got scripting tools, you've got configuration management tools like Ansible and Puppet and all of those things. You've got templating tools. You mentioned some, I think I would maybe even throw in Docker and Vigor and things like that. But then you've got provisioning tools, and that's really where is that a fair statement to say that's really where Terraform lands?
Well, the thing I was getting at is while everything else has moved and become so much more approachable, being dragged along, I would say, by public cloud, the network is still pretty arcane.
Yeah.
Right. Even, a network expert, making the jump from a familiar platform to an unfamiliar one, right? That's a scary jump.
Yeah.
Right. I don't want to deal with that vendor because I don't know the CLI. It's, it's too hard. Right. That kind of thing. So the idea of
the kind of core topic of this is we've been talking about abstractions and right level of abstraction. It's core topic of all our shows.
Okay, so this is not new here.
Whether it's related to services on top of this, building abstraction at right layer, kind of avoiding clicky abstractions. It's really core topic, and I think Terraform greatly unifies all of those, being able to provide kind of single input, multiple output layers to automate not just networking, but storage and all other cool tools that you've mentioned.
Yeah, I mean, it makes most of that stuff much more accessible, easier to drive, and it automatically enables integration between them.
Yeah.
Right. So if I want to, do something with vCenter and AWS and an Infoblox box and a TLS certificate, right? That's one Terraform document that integrates all those services and use values from one when doing the work on the next one, and passes things around, and you can do an app deploy, including all of the things you need to touch and all those different stacks as one process. But to a large part, the network has not lent itself to that, right? In the network, we're still talking about, being an arcane CLI expert and pushing configs to box by box. So yeah, when I got to Juniper and saw Apstra, I was like, oh, this thing's the abstraction presented by Apstra, a perfect fit for Terraform. We got to get on this.
Yeah.
So that's where that's where this started, I guess.
Yeah, we a longtime guest or many time guest that we've had on here, and actually haven't had in quite a while, is Jeff and I's mutual friend Russ White, and Jeff and Russ have a book out on managing network complexity. I have it right?
Navigating network complexity.
Navigating. I'll see. I can manage. I can manage.
You can't manage it. The best you can do is find your way through.
yeah, and but the whole point of it is being able to look at the network holistically. Rather than there you go. Thank you. You've got the official plaque and everything.
Yeah.
I've got the book around here somewhere. But the whole point is being able to look at the network holistically, which is hugely important, rather than looking at it as, I've got these switches or routers of these particular vendors and these servers and these firewalls, and and then having to look at it of, well, what's the vendor and what's the what's the operating system I'm using there. And Terraform allows you to get that holistic view, right?
Yeah.
Oh, sorry, Raj, go ahead.
No, I was gonna say, like, the other interesting thing that Terraform provides is the kind of the difference between imperative and declarative model, right? So the imperative model says, like, it if you need a car cleaned, it tells you everything you need to do to clean that car, right? Get the cloth, get the buffer, get everything, clean the car. Whereas an imperative model says clean car, and then the provider, or like the cleaner in this case, or like the provider in Terraform's case, goes and takes care of cleaning the car. And that's I find that like very, very powerful, right? The to like uh, uh, speak of a personal anecdote. I got into programming, right? And then the first time I had to program network devices, it took me a few steps to understand that the configuration that you put into a switch or a router or anything is state. It's not commands. You know what I mean? Like, we think of them as commands, but it's actually the state on the router or state on a switch. And to me, that was mind blowing, because until then, you write code. Code does things. Even when you go into like object oriented programming, it does things. Whereas what's happening in a network is there is a state of a network. There is, like, there's a state on a switch, and then that state causes the switch or the router or the firewall to like drop packets or like route packets or whatever. So that's another very interesting intersection where like Terraform makes so much sense once you understand that it's all about state.
Yeah, and I think in data modeling world, we kind of clearly separated. That made life so much easier to have clear separation between configurational to derived to operational states, right? There are different kind of places you can compare one to another. You could figure out, if I apply this configurational state, what should my operational state be? And if my derived state is not in line with my operational, something is wrong, right? So having this clear separation of concerns, it's very, very powerful.
Yeah, I think having a higher layer abstractions even than network services, right? I mean, a network service could be, one VLAN on appearing on an interface, or or the idea of an access control list or something, which, you know, to build a sort of business focused application service, you know, a network outcome requires a whole bunch of little fiddly state details off across a whole bunch of devices, and you know, getting all those working together and doing it right every time is a real high cognitive workload on administrators.
Yep.
So, Bill, you've been very quiet.
Well, there's
You chime in?
the big thing that I got out of, you know, my exposure to Terraform coming from like you, Jeff, the old CLI, you know, knuckle dragging network engineer, right? That's me, right? So look, you know, when I first realized that we can use a state-based declarative, it took me a while to grok declarative, right? To be honest with you,
Yeah.
right? Declarative, the first time you see declarative, you're like, I don't understand. Like Raj was saying, you know, I used to program and I've been in the switch and route world forever. But, you know, you make some, you know, VLAN configuration, put some ports in there. But that's an active imperative operation, right? Not a declarative operation, right? You're not looking for the outcome. You're just looking for something to do something. So if I want to take that VLAN back off or change that port again, I have to do another imperative operation. With the big, you know, light bulb went off with me when, you know, the way to do the same operation with, you know, Terraform would be just delete that part of the Terraform configuration, and Terraform takes care of that removal for you, right? You don't have to go in and implicitly type in, oh, I want to take that away. So I think from a service operations perspective, you know, Terraform brings a whole new level of capability to take and gather, you know, what you want things to be, and then follow that up with, you know, or to expand on that. I'm no longer just operating network equipment. I'm operating other parts of the stack, right? Chris can configure. I mean, we did this thing where we can configure install packages in, you know, Linux devices. We can do load balancer or firewall configuration and put that all in the same block of Terraform, such that you're operating on multiple levels of the stack. And so if you do want to have that service anymore, you literally can take that entire piece, pull it out, and Terraform will take off the parts that you had placed on. But that to me was, you know, that's when the light bulb really kind of went off. And that's when I appreciated the work involved with these providers.
That state maintenance thing is really key, right? It's not just about, you know, deploying the configuration of the boxes, right? It's about you know, offboarding the source of truth of what is supposed to be in your operational environment from all the devices and services and APIs and whatever, where you put them into a bunch of files that you can share with your peers, that you can, you know, version in GitHub, that you can do peer review with, that you can submit to security scans, that kind of thing. If you know, if we think we were going to use Terraform to like furnish a house, right, you might say that like, oh, there should be, you know, a couch in the living room, it should be blue, there should be a television on the wall, there should be, you know, plates and cups in the kitchen cabinets, and a bed in the bedroom, and, you know, you just define all these things that need to exist, and that's it. The Terraform configuration document is literally just a description of what should exist, what types of things, and whatever attributes those things might have, where they should be, how many of them there should be, that kind of thing. And
Does that go when you say it defines the things that should exist in the network? Does Terraform go beyond that? I mean, would it replace something like Ansible for you know, for defining the actual configurations on the devices?
yeah,
That
I mean,
sort of thing, or
a lot
is
of
it?
people use Ansible in concert with Terraform, but you can use just Terraform to define the state that you want, right? So if we stick with this house analogy, right? The house is initially unfurnished. You define a bunch of stuff in a file, and then Terraform will, you know, handle the problems of getting a personal shopper to go buy your furniture, getting movers to install it, you know, hiring painters, getting the walls the right colors, all that kind of thing. And then you have a house that's set up the way you want. You have a document that describes how that house is supposed to be set up, and they match because we've just run the project. Subsequently, you know, if you've maybe it's an Airbnb, you've rented it out, right? Well, you run the Terraform project again, and Terraform revisits every detail that was in your document and makes sure that all those things are the way they're supposed to be. And if a room has been repainted, it will be corrected. If a piece of furniture is missing, it'll be replaced. If some other object is some attribute has been changed, that attribute will be changed back. So whatever it is, you run the project a second time, and just everything is validated and corrected.
Continuing with some analogy, I think you can build everything correct, but then you could put your sofa 30 centimeters away from the TV, right? Which should make it pretty much impossible to watch. So we might see it from angle. Now you can break your network at scale, which is always great. I think the problem with configuration has been mostly solved for about 10 years, right? I mean, configuration is easy. Reconciliation of state is not. Ability to understand where you are now is where you want to be, and if you aren't, what's missing, what's too much, what's too little. And I think this is where Terraform provides really interesting and unique capabilities, really understanding the operational state and deltas between what it is versus what it should be.
But if you're doing just routine day-to-day configuration changes, is Terraform still the right tool to use there? I mean, you're using Terraform to deploy your network and provision your network, and like you said, define all of these things. And you said you can, use it to define all the way down to configurations. But say, just I'm running a data center network, and I need to, add a VXLAN, or thinking of something off the top of my head, just routine kinds of configuration. Is it still a good tool to use there, or should you?
If you run Terraform for an initial config and then you abandon it, right? That's okay, right? Your devices, doesn't really matter how the configuration got there in the first place.
Yeah.
Whatever the services or devices are, you can point and click or type commands or whatever it is to change things however you like. If you subsequently run that original Terraform project again, and you have changed things like the viewing angle of the couch to the TV, or the color of the towels in the bathroom, or whatever it is, Terraform believes that it has the official record, the source of truth, and it will correct those things in its view.
Okay.
So now it will correct those things for the object it's managing, right? So if it's managing the couch, it will correct whatever conditions are relate to the couch. If you bring in some other piece of furniture, Terraform will disregard it.
Oh, okay.
So it depends. There's lines you can draw about, like, oh, these are objects or attributes we manage with Terraform, and these are things that we just manage ad hoc, kind of thing. I would say that most shops that adopt Terraform do it because they want the text record of the state, right? Because if you're making ad hoc changes, especially if it's someplace like AWS or Apstra or something that's very sort of point and click environment, tell me how your network is configured. Tell me how your AWS environment is configured. Go ahead and like, are you going to give me screenshots? Like, what does this documentation of your environment look like? Or for that matter, if you're proposing a change to be reviewed in a peer review process, right? What does that look like? You putting screenshots or descriptive prose about where you will left and right click into a Word document and bringing that before your change review board or your peers or whatever. So shops that adopt Terraform generally use it because they want to use it. They want to pull the configuration state out of all of the different places where it lands and collect it in a very human readable textual form that can be versioned and shared and backed up and whatever.
Yeah, and Jeff, I would venture to mention there that that's a journey for most knuckle draggers like you and I. Just acknowledging that there is a problem, or the elephant in the room is that the humans often are the cause of the issue. We tend to be responsive and sometimes not the best at taking the whole picture. And so, we can make changes, and those changes can cause more problems than they're worth. And a lot of times we don't want to let go of the capability to log into a device and make a change directly. Making us go through a workflow or a change process is something that I find, initially resistant to, right? I'd like to be able to just, like you said, I just want to log in and make some changes. I know what IP address I want on this interface. I'll just change it myself, right? And get it done. And that's great until you get to the point where you're at a scale or you're at a level where there are multiple, I guess, people involved that are making those changes or systems involved. And then you have to keep track of how those changes are occurring. And there's things like time zones and people in global areas across the world. And then you complicate that with, change windows and all those things. Having the structure of infrastructure as code, Terraform, or some other mechanism with Git, and doing things like change requests, pull requests, and then getting those, acknowledged, that workflow. I think it adds a level of adult behavior to the previous lack of that as we grow up in these infrastructure setups. And like Chris said, how do you document these changes? If we're running from a graphical user interface or even a CLI, that can be difficult to document what changes you want made unless the CLI is easy to do that with, and it has to be designed to do that. So those are just some comments that I've seen. Like Chris says, when an organization decides to use Terraform, well, like I said, that might take some thought leadership, strategy involved in making that decision. I see guys are nodding their heads. So yeah, that's
and I think a lot of that is just administrative policy too. Of if you're going to adopt an automation tool, Terraform or whatever, you got to watch out for the old CLI jockeys that, to use your example, I'll be really quick. I'll just log in and change this IP address, and, we need to get our hands slapped for that because,
Don't worry, we'll put it back.
yeah, exactly.
We'll switch it right back to what it should be.
What's happening, right? Suddenly you see your BGP table and your OSPF, and
It reminds me of the cabling, right? When you go into a data center and you look at somebody's cabling infrastructure and you kind of look at it for the first time, you see cables literally just plugged in, whatever color is going, whatever. There's no organization, and you kind of look back at that and go, maybe some prior planning would have been
exactly
helpful here. And I look at configs the same way in terms of how we can address this, and maybe you need some adult guidance from a tool set like Apstra or any other tool that specifically it's Apstra's job to manage the actual device config. Whereas, Chris is not writing, the code of the Juniper switches or the Cisco devices in Terraform. He's just telling Apstra, go and do this thing. And then Apstra goes off and does the code development. But any tool set could do the same thing. When you go into Amazon, you don't say, hey, I want to configure, the layer 2 switch inside of my, VPC. You tell Amazon, I would like to have this service or this, this network or this VPC, and it creates it for you, right? So you're not back in the weeds of trying to figure out what they've done in their infrastructure.
Yeah, I like your example of the cabling, and I mean that ports so well to what you see with configurations too. The other side of it is, sometimes you see these beautiful new cabling jobs in a data center. We've all seen the pictures. They call them cable porn. It's like, that is just so pretty. And like you revisit it 2 years later, and it's going to be a disaster in there.
Yeah, to Bill's point about not, slamming in the individual commands, I'm real cognizant of not turning this into an Apstra commercial, but we wouldn't have tried this against the devices directly, right? It's only because Apstra gives us the high level abstractions where you can say like, my fabric should have a VRF, and that VRF should have, a network in it, right?
Yeah.
Like, that's 2 API calls to Apstra, but it sets up, potentially hundreds of lines of config on potentially hundreds of switches. And
which is great kind of continuation. Not everybody has Apstra, and indeed, we don't want it to be a commercial for it, right? So practically, imagine you need something below your Terraform, and at some point in life, we all work for Apstra, so we are familiar with kind of guts of the infrastructure, how long it took to build the database to be able to express all the relationship between different objects. It was years of work of hundreds of people, right? So it's anything but trivial. But given that if you don't have a commercial product, probably you don't have anything like that. So how do you see kind of state reconciliation and translation from high-level objectives into indeed VLAN configuration? How would people do it without having commercial tool?
Specifically with Terraform, but
Yeah,
against
this is the
I mean,
question.
so Terraform, at its fundamentals, right? It deals in terms of objects. So anything you can define as an object, and on those objects, it can do 4 lifecycle operations, right? Create, read, update, and delete. And if you can boil your infrastructure down into creating and maintaining and deleting objects, then you can Terraform it, provided that there's a provider that will do those operations. And there's hundreds or thousands of providers out there. These are plugins to Terraform. And if there's not one that you want, you could write one. But the network is a particularly thorny area for thinking of in these terms.
So this is kind of day zero problem, right? How to logically design what you want to achieve and configure it. When you start going into day 2, 3, when you need to bring changes, you need to provision new tenants, you need to provision new ACLs, any changes in the network, you're really interested in the end result of the change, right? And we're talking distributed systems. So it's not just state on this particular switch. It's a combination of states across all switches or routers that eventually will result in correct state. How do we do this in Terraform?
Without talking about Apstra, I don't know that we could.
Yeah, without.
So in theory, right? I mean, I'll just take this and take a swing at it. In theory, you would have to define your own objects, right? So there's no Apstra, right? So you have Terraform and you have your network. You would have to basically design your objects, and then your provider would have to take care of all the abstracting of the network to say if I have this, I want this VRF in my fabric, then your provider would have to take care of uh, doing all the provisioning, right? So in our case, Apstra is sitting in the middle, and the abstractions are already defined. So if Apstra didn't exist, let's drop Apstra from the picture, then for you to be you can do a naive thing where you're basically just using a provider to dump config in, which you've not gained.
I think
much
your
of
objects
that
would
from.
get real small and start looking like
Yeah.
configs.
Yeah.
Right? It'd
Yeah,
be an
like,
object that defines a BGP process and another object that defines a BGP session within that process.
right. But
And you'd be going box by box.
right.
Yeah, so again, I think configuration is kind of solved problem, whether it's Terraform or something else driven, Jinja or Ansible. At the bottom of it, we know how to do it. So the question is really how to reconcile states in a way you can define state of the service. It's working, it's not working, right? And it could, or not only could, in most cases, it would involve multiple devices that have different pieces of configuration that eventually will result in the single state. Moreover, your telemetry consumption system or ecosystem is probably completely decoupled from this, right? You might have some OTLP or GNMI collectors, SNMP system that gets something, syslogs. How do we reconcile all of this so Terraform, being the top level provider, can decide, I did my job, I could move on?
Yeah, and you really need some type of, I don't know what you want to call it, but some type of job process or orchestrator type system that would do that for you. Like, for example, AWS provides that functionality through an API, and then somebody wrote a provider in Terraform to tickle the right things in that CRUD chain, right? And so the same thing with F5. When we first came out with it, the F5, it was fully imperative API, and it was like horrible. And then they came up with this thing called AS3, which sits on top of that and basically takes declarative statements like, hey, create a pool member, right? And put that in a load balancing virtual server. And here, I'm going to send you this block of code that defines that. And then, AS3 would then take that, break it up, and do the actual imperative commands in the back of the F5 to do the work. But you still need to have, like I said, that kind of interface that is between Terraform and the end device.
You would basically
decide to do that.
You would basically have to define your abstractions somewhere, right? Like so, like you need those abstractions to model the real world, to kind of use like an object-oriented concept, right? Like the object models the class models the real world. So you would need to define those abstractions, but maybe like you have to solve a very particular problem in your fabric, so your abstraction can be very, very tight because you aren't trying to solve a general problem, and then you can create your Terraform provider that matches that problem, and then now that matches the abstraction, and now your config is going to be a lot simpler. It's going to be able to express the change that you need, be the change you want to be in the world, and then you can do Terraform apply.
Well, you see, there's a not conflicted objective, because if you go vertical and use apps and netqueue, I don't know, Nexus dashboard, probably, I mean, the value of Terraform as top-level provider is still there if you go very wide, but practically you don't need it if you just do networking, right? Well, the idea of Terraform as such is to go really wide. So you're able to configure your infrastructure so it's not just the network part of it. So the interesting question is really, how do you align all of this? So when you provision the service, and we all want to provision services. We don't want to provision VLANs and IP addresses, because the real value is providing service to your customers as soon as you can.
So provisioning services, right? We can stack abstractions, right? So we have whatever abstractions are provided by the APIs we're consuming, whether it's from the a box that does DNS and DHCP, or something that provisions network services, or load balancer or whatever. And we can, with Terraform, assemble those into even higher layer services that would be like an application deploy, right? So if we've got a developer needs a sandbox application to test against, and that thing's got a front-end web server and a database and some load balancing rules and firewall policy and DNS and all these things, you can put all that in one Terraform project. And like Bill just mentioned, adding pool members to a load balancer. Maybe we provision 2 VMs and those spin up, and then for each of those VMs we learn an IP address that it chose when it came up, and then we take those IP addresses and we make them pool members in the load balancer, and we add firewall policy for those 2 specific addresses that came in. And so we'd be reaching all over the network, touching all kinds of different products and services that together build your on-premises or cloud application deployment. And now we have an abstraction that is an application deploy.
The question to you is really, again, kind of avoiding underlying infrastructure, which I know you've been working on Aptra for a long time. It's really, can we pull up some of this logic into Terraform? So rather than having per vertical tooling giving you binary, I'm working, I'm not working, having something more intelligent Terraform that actually able to gather from the, I don't know, telemetry collected something to be more intelligent, just saying it's working, it's not working, and then having logical end of event saying if everything is true, then the stuff is working. If something is not true or false, it's not working.
I think Terraform doesn't know if things are working, right? It's not an operations management, alerting or that kind of system at all, right? Terraform only concerns itself with creating objects on, whatever platform it is we're automating. So that creation of a VM, right, in VMware, let's say, doesn't mean the thing booted correctly, right? It's just we were just supposed to make the VM exist. If it came halfway up and crashed, well, you asked me to make a VM, I did. Right. So you would, probably be terraforming, rules in your monitoring system at the same time to go with that application startup.
So you do see Terraform kind of driving the telemetry subsystem that will allow you to reconcile and say, not only I asked this object to be created, I actually got report of successful creation of such object.
I mean, that is a table stakes with Terraform, right? Terraform reaches out to whatever the API is, makes the thing, collects the ID of the thing, and that's that. Now, there may be attributes of the thing, like in an EC2 VM, maybe we say that the state should be running, right? And when you run Terraform again, because Terraform is a command line, right? It's not a service, so it's a command line application that runs, completes its task, and exits, and at that point, it's over. When you run Terraform again, if you have said that an EC2 VM must exist and its attribute must be running, then we'll push the start button for that VM. But again, we don't know from the perspective of Terraform or the AWS provider that Terraform relies on what service that VM is supposed to be supplying and whether it's working.
Yeah, like Terraform is not a monitoring tool. Like that's like a very important.
Yeah.
Sure.
notion.
The question is more towards reconciliation, right? Do you need to build something on top of Terraform that can do it aside of Terraform? We're talking about abstraction. So the question, where do you put what, really, right? Because the end result, you want to provision service, you want to make sure it's working, and if it's not working, you want to understand why.
Mhm.
That's pretty much the business logic, right?
Yeah, so in that case, you would provision, monitoring rules in whatever your monitoring system is to go along with the object you're creating and whatever the actual target systems that you're configuring are.
So Terraform could define a VM using your example, but if it crashes as it comes halfway up, you need something else to tell you, oh, this didn't work.
Yeah, but Terraform could start that process as well.
Yeah.
Right. It could
Okay.
create the VM and create the watcher.
Yeah, as long as the provider for all these different elements, you would take objects from those different providers and you could get state information out of the state machine for that, right? So you could check, oh, I'd like to know what's the state of my VM, and it could say started, right? And then, well, okay, but I want it to get to running state, so I'll just hang out here until it gets to running or something to that effect, right?
So practically, we are saying that reconciliation can be done within Terraform.
Terraform and other tools that,
Yeah.
whatever you would already be deploying alongside these services if you weren't using Terraform.
Imagine you're in a beautiful greenfield, and you're just thinking, how should I build my business logic stack so I can make provisioning seamless? And I think this is kind of the dream of everyone building at scale.
Well, not only that, but you have to look at the maturity of the different tool sets and providers that you're looking at, because some of these tool sets are new or providers are new, right? And some of them are very well utilized, right? So for example, if I was going to look at the Amazon E2C provider or whatever you want to call it, that VPC, that thing's been used like probably, I don't know, millions of times by different people. So it's probably very mature and very well documented. And I've looked at other providers that they're not. And so you got to make sure that what you do choose does have the capability that you're looking for, what that might be, right?
So we've been talking about Terraform for what 43 minutes now. You guys brought along some things to show, right?
I have a demo.
Yeah, we would love to see that. So
cool. So this demo is a GitOps style demo. Let's see. Are you seeing my screen? Do we have that up?
Yeah, I've seen a very familiar screen.
Okay, I'm sure you would find this.
Yeah, recognize. Yeah.
So this thing is
watched
Astra.
the show much has seen that screen.
Let me just bounce through a couple of slides because there's a slide that helps me tell this story. Okay, so Abstra, right? The point is to avoid all these independent command lines and thinking about individual switches in the network, and instead, consume a web UI and sort of a unified fabric view. Some folks, love the GUI and find that this notion of like, wait, I'm back to text, right? This seems like a step backwards. You gave me a lovely GUI. Why would I want to deal with text files again? And of course, we discussed like, well, you can version them, you can share them, you can subject them to policy review, and all those kinds of things. Here's an example of creating something in Abstra, right? To create a routing zone that's a VRF in Abstra, you're required to navigate into the right network context. We call it a blueprint. Specify the name of the VRF that you want, and a couple of other attributes. Doing the same thing in Terraform is a text file that basically says what type of thing to routing zone. We have to say where it's going to go, which blueprint, which we did in the GUI, and then name it and some other attributes. It's if you were going to send me an email asking me to create this thing by pointing and clicking, your email would look a lot like this, right? It's not scary code. It's pretty straightforward stuff. All the documentation is online. There's a standard library for reading online docs. If you're looking at Terraform providers or considering vendors, I would definitely have a look over here and just browse through the docs real quick and see who's serious about this and who's not. And the Git argument here is that it's not just one admin in most cases, right? We're going to have a bunch of people all editing the same file or files, and we need a way to reconcile their edits. And that's put the thing in Git, right? Developers have solved this a long time ago. There's a merge reconciliation process. Everybody can edit the same things. We can run proposed changes through a review process. Well figured out. And once we're in Git, whether it's GitHub or GitLab or whatever you're using, you've got CI now, right? Continuous integration where you can run scripts on these changes and actually automate the process of approvals and whatnot. And what we're going to do now is, well, once everything's been validated, why wait until Friday night to push the button? It passed your tests or whatever it is you're doing, so should be safe to go to prod. Let's just do that. And let your CI system just do the deployment automatically. This demo envisions a VPN connection at the edge of your data center fabric. So there's a router there. It's attached to the fabric. We're talking BGP to that router. That router has, say, IPsec connections to third parties. And at where that router attaches to the fabric, there are policies so that we only send and receive the routes that we expect or need to send to each of those partners. So within Apstra, there's a couple of objects that tell that story. This one right here, this is the building blocks of configuration at the edge of the fabric, right? So it's a routed link, a BGP session on that routed link, and then 3 policies applied to that BGP session. And the policies, there's 3 elements in here. If we look at them, so I've got these 3 policies: vendor A, B, and C. And if we'll look at vendor A, you see it's allowing some specific block in and a couple of blocks out, whatever it is we have. In Terraform,
so Chris, if I can interrupt for a sec.
Sure.
In the absence of Apstra, you would need, like, it doesn't have to be Apstra, right? In the absence of Apstra, you would need to have another system that defines similar abstractions.
If we weren't using Apstra, ultimately we're writing configs into one switch, right? One router, whatever it is. That it's a BGP session. It's got policies applied. There's filters, and every vendor does it a little bit differently.
Well, so again, to kind of my question, we know that backend is still Ginger, right? So whether you use Apstra or something else, the kind of population of configuration is going to go very similar way, and it's mostly solves problem. The more complex kind of question and technology to be used, and again, I want people who watch this video to understand what they can do without buying from a vendor, right?
Yeah.
This is kind of the goal of the show. How do I know that after I have applied all of this, it's actually working? Right. And
I mean, without Terraform or without Apstra, what would you do, right? You'd probably have something watching BGP sessions. You'd probably have something validating that the services on the far side of the link are available. Those kinds of things.
Again, hearing and understanding that 2 different concepts, right? You might be seeing what your BGP is doing, but how do you understand that what it's doing is actually what it should be doing? Whether your operational state is that of intent, right? Again, without using some very intelligent tooling that Apstra provides, and I'm kind of still proud of, right?
But I mean, even with Apstra doing its job correctly, or your whatever other configuration engine you're using doing its job correctly, right? We don't know that the VPN connections across the internet are working, right? So I mean, we still need validation outside of this, and Terraform is about configuring services. It's not about validating operational state of services. So you would need something doing tests, and if that thing was composable, then you could compose it with Terraform.
So, but this is layer below, right? I'm talking really about something that could be in parallel Terraform or actually on top of Terraform, where Terraform provides configurational logic, but you need something else that will provide kind of state comparison, reconciliation on top of it. So again, it's an interesting question, and many people or most people don't know how to answer it. How do I put my different layers so I get vertical?
Are you saying like if I was terraforming in F5 and I was trying to add a member to a load balancing pool, how do I verify that happened? Or if I was terraforming a DNS service, how do I verify that the DNS record is published and available on the internet?
So obviously,
at some point you put faith in the services you
go to some kind of route server on the internet, or you try, I don't know, Google DNS, you do a lookup and you see if your record is there, right?
Right, and so whatever the service is, right, you need to find something that can act as a validator if you require that.
This is low level logic that we need it, and it's actually below because it goes into IP addresses and VLANs, which you don't want to know about. The question: how do you compare publishing and your record to service working? And you need more than just DNS, right? You need proper propagation of routes and BGP if you are using something new. There's a whole bunch of things that are coming from different types of technologies. And again, my question: can you try to build some reconciliation of the stuff in Terraform, or you need to build something on top that would actually decide the service is running?
Yeah, I mean, Terraform won't take responsibility for that, but Terraform could provision the thing that you decide is the appropriate checker. Now, I mean, even if we did that, though, we could chase we could chase our tails forever here, right? How do I know the checker is actually checking?
Who's checking the checker? Yes.
Right. So I don't know. At some point, you assume that if you asked VMware to create a VM or to create a port group or whatever it is, that's going to happen. Or if you asked Route 53 to add a DNS record, that's going to happen. If you feel the need to check it, then check it.
Yeah, I think we're talking like two kinds of reconciliation here, right? Like one is what is the state of the environment and what is the outcome of what you wanted to do. And I think like those are two like slightly different problems.
Yeah, also different.
Yeah. So the state of the environment, based on how the Terraform provider is written, can be very accurate, right? Because the Terraform provider, when it goes out and does a create operation, it'll update the state, and there is a read where it can read the state, and that kind of like state reconciliation will be taken care of by Terraform, assuming the provider is written well, right? The question of like the outcome reconciliation, you would need like a monitoring tool. Like, is my website up, right? Like ping the website, make sure it's like it's up. That has to happen outside of this picture. And then if the website's down, this monitor can decide what to do, like maybe redeploy, maybe delete, maybe, like, you know what I mean? So like I think we're talking like two levels of reconciliation here. I think that gets closer to the question you were asking, Jeff.
Yeah, so I think the question is, can you build this kind of set of building blocks in Terraform that, depending whether true or false, would allow us to tell end user, is your service up, is it down, and potentially what's wrong?
Yeah, that would not be an appropriate use case for Terraform. Okay. Terraform is just about creating configurable objects. And once Terraform executes, then it's over, right? It might not run again for weeks. It won't know if things are working. It's not even, doesn't even exist.
Yeah,
even ideas to do it kind of more on demand, so event driven in a way, right? So you run Terraform when particular event happens or some state becomes true or false, and you rerun everything. Is there such machinery?
I mean, one example of that is you run Terraform when a customer makes a purchase or a request out of a ServiceNow catalog, right?
Now,
So
this
you
kind of
could make a network
this is
service
an
catalog
explicit,
item.
this is an explicit call to configure something. I'm not talking
Yes.
about changing the state of the system that would trigger a run. Do we
I
have
mean,
web
you can just run Terraform and as a validation, right? Make sure all the things that existed last time it ran still exist and are still, have all the correct parameters. So that's certainly possible as a checkpoint revalidation. But that still won't answer the question: is the website up? So I'm not sure how valuable it is for that kind of thing.
So can we build some kind of a loop event that is waiting for change and trigger some action in Terraform itself, or it has to be external to it?
It would be external.
Okay.
Yeah,
Thank you.
Terraform is just about composing the state of whatever services you're using and imposing those state objects onto those services.
So we've set the stage for the demo.
Okay. Yeah. Sorry. Okay. So we've got, right. I showed two things here, right? There's the detail of the configuration at the edge, and then also these routing policies that relate to this picture, right? The 3 policy documents for the 3 partners. This fabric was built as infrastructure as code, and this document is an example of the kind of thing that an architecture team might hand off to ops, right? So if you want to change, VPN service partner routes, just come to this document and make your changes. So we saw we had vendor A, B, and C in the interface configuration, and also routing policies for vendor A, B, and C. We looked at vendor A and we saw these 3 prefixes. Vendor D is here commented out, but I'm going to add it, and I'm using the Git web editor thing to do it. So let me just click in here and take the comments out. And
This is really simple and
yeah,
readable.
Yeah.
and so even because we talked about, like, well, a service outcome, even an app store that handles lots of things, you still might, to light up an actual business outcome service, you might need to touch a few places.
Mm-hmm.
This is an example where we've simplified it all the way down to what this organization needs as a typical ops workflow. So I'm going to commit this document. This takes me through GitHub takes me through the GitHub PR process. So a proposal of changes that would be reviewed by someone in my group. And this is the open a pull request page. I would describe what I'm doing. Perhaps I would add Bill or Raj to do a review. And we'll do create pull request. So my changes are not live. They are in a separate branch. They are merely a proposal. So we'd be going through the review process at this point. Somebody would get an email saying that they've been requested to do reviews. They'll come in and check the box. Maybe if I have an automated compliance process, maybe that would be looking at this proposal right now. And in fact, you can see from this little thing spinning here that the GitHub Actions bot is looking at it. And the GitHub Actions bot has just weighed in on this pull request with a comment. And the comment says, well, if we merge this change, here's what's going to happen in the network. We're going to make some changes to routing policies. We're going to make some changes to configuration on ports and so forth. And all of the adds and removes from the state of the network are enumerated here. This is Terraform reports diff syntax. And I'm just going to go ahead and merge this. I don't have any reviews, but I do have a bypass button because I own this project. So I'm going to bypass all the safety valves and merge the thing. And if we pop back to our web UI, you see there's still only vendor A, B, and C policies here. We'll go look at that connectivity template, vendor A, B, and C. D has just appeared this second. So now the vendor D routing policy must exist. It has been attached to this this BGP process. And we'll go back to routing policies, and the vendor D policy is here now. So this is a pretty modern, DevOpsy, GitOpsy way of operating things, and customers are really doing this, and I think it's pretty exciting. I like that we can roll back to the state of things from before this change. If there had been a bunch of changes going on and one of them was a problem, we just roll back that one merge, right, and get the take out an edit from earlier this week while leaving all the edits that people had made subsequently. So it's a pretty powerful system, and I like it a lot.
And the cool thing is, like, this is the software engineer's life, right? Basically,
Yeah.
make your code change, get a PR, like create a PR, have people comment on your PR. Everybody blesses it. The little thing, make sure that you did all your linting right, and then then it gets pushed out. And that's a software engineer's life, right? And basically becomes this basically becomes like a network engineer can do this too, right? And and kind of the cool thing is, or the cooler thing, or what this allows us to do is that this network change can become part of a much larger, like software deployment, right? So
Yeah.
this PR right now showed a network change. It could also show the deployment of the application that's going to be using this VRF, right? That whole thing can be like one. There can be like one PR or multiple PRs, and then everything gets reviewed and everything goes out. It's like that's the real power of using something like Terraform, right? You join the mainstream, the herd,
Yeah,
whatever.
it's kind of CI/CD way of doing things, right?
Yeah, you're one of the cool kids now, not the arcane kid.
This
I'm
particular
going to
example,
say,
I geared this example to show that it's a constrained interface, right? The only things I could edit in that file were details of routes, but on the network service that we were interfacing with, we changed a few objects, right? Well, we created an object, a new routing policy, and then we modified an already existing object, which was the thing that describes the connection at the edge, and we included that brand new policy in that existing object.
question to you with regards to validation of data. Can you do some initial validation within Terrastream, like with data typing, say that the input is IPv4 address and it cannot have more than particular number of fields, and fields have to
this is not freeform, right? This all the data types are fixed. The validation is there. If you put an IPv4 address where it expects an IPv6 address, that this process would stop very early.
And it would be stopped by Terraform itself because it understands the semantics of the input.
Yes, the provider defines the inputs for each object that it supports, and there's validation on that stuff. So even though we supply IP addresses as a string, right? It's got quotes around it, and it's just a string. The thing that it ingests that data knows that should be an IPv4 address, or that it should be an IPv4 address insider notation with a bit mask length.
So from ownership, who owns the provider, the piece that does the validation? Is it part of, say we have Terraform team and then we have networking team? Who owns this?
The architecture of Terraform, like the application, right, is that HashiCorp wrote Terraform, which is basically just a diff engine, right? It can compare states, and those states that it's comparing come from the providers, where the provider is an application written by somebody, which knows how to integrate with a given network service. So we have a provider for Abstra that we wrote. I've written other providers. There's a provider for AWS, probably F5 wrote a provider for their load balancer and so forth. So you use whatever provider it is for your service. And this is where we were getting into that sort of quality question. Like, there are some providers out there that, will have a very simple to use interface in the sense that, like, there's not too many inputs, but the input that you get is device configuration, and it's 5 miles of JSON in a string, right? So those kinds of things exist, and that's not very good. The better way to do this is to know all those attributes exactly and be able to identify each piece of data, which is what we have.
So practically, looking at kind of classical organization, the provider piece would be much closer to infrastructure than to kind of cool kids doing Terraform. They need to understand semantics and what's actually being fed.
Yeah, when you consume a provider, so Terraform, I'll just look at our docs for a second. So if we looked at, say, how to make a tag in Abstra, right?
I'm not sure
Here's
the screen is shared.
oh, did I have the screen off, or did somebody turn me off?
Oh, let's see. Tim, can you add the screen back? There we go.
Okay, so this is the documentation from our provider for how to make a tag in Abstra, and there's a strict schema that describes what's supposed to be in a tag, right? And it has name and description, and when you create a tag, you get back the ID that was chosen by Abstra. For a more complicated object, let's take something in the data center ref design, a connectivity template, for example. There's a large schema here, right? So when you create a connectivity template, at a minimum, you have to supply where we're going to put it and what is its name. But then there is all these extra things that can go in there. In the case of IP links, this refers to like /30, routed handoffs. If we look at IP links, see below for nested schema. The schema for an IP link includes, rules about IPv4 and IPv6 addressing and what VRF it belongs to. And so, all of these things, like we know, that they're, that this is a string, but only these values are permitted, for example. So this schema is very strict.
Okay, that's clear now. And it should be living somewhere where people really understand the semantics of the consuming system.
Yes. So the idea here, I mean, very likely if you were a Terraform practitioner, right, an end user using Terraform to compose your infrastructure, you would probably have 3 documents open on your desktop. You would have our documentation. You would have you'd have the Terraform provider documentation. You would have the system documentation, whether it's the AWS guide or Abstra guide or whatever, and you would have your the GUI for whatever the service is. And between those 3 things, like, you should be able to match up the values. Like, oh, here's the value I see in the GUI. Here's the same field described in the product manual, and here's where that field appears in the Terraform provider documentation. And in a perfect world, those 3 documents will be in perfect sync.
Okay. So practically, this is your API description. It's contract between provider and consumer.
That's correct.
Yeah.
Okay.
So we're about 7 minutes over the top of the hour. I guess we should start drawing this to a close. That was a great demo. Thanks.
Yeah,
Thanks,
and
Chris.
very exciting topic. Thank you.
Yeah, it is. And so my last question is for anybody on here that has been watching the show and says, "Okay, this looks great. Where do I get started? How do you get started with Terraform? What's the best way to learn?"
There's a lot of courses and a lot of people trying to get your attention for how to on YouTube and other places. It is surprisingly easy. If you could send an email asking someone to provision, whatever it is on whatever service, you could write the Terraform config that does the same.
Yeah, cool.
And have you tried one of the LLMs to do it for you? Does it work?
I imagine it does. I don't use them for that. In fact, the editor that I use, lots of editors have Terraform plugins.
Yeah.
The one that I use, automatically pulls the Terraform documentation. As soon as I start a stanza of a given type, it knows what fields are required, and if I start typing the name of an optional field, it'll complete it for me. So yeah, there's a lot of help of the sort you would expect from a good IDE.
Yeah.
There's a lot of good books out there too.
There's
honestly,
there's YouTube videos, and there are pay for classes that you can take from companies like Udemy that have instructor led type courses, and there is a certification, I believe, for Terraform as well. But the Terraform courses that I've taken are using like the AWS provider, which is you don't have to have any. You don't have to pay. Terraform is not a pay for. It's open, so you can just download it and run it, and you can go to the free tier of AWS or Azure and use their providers, and so it's very accessible to learn.
So basically, however you learn best, there's resources for you out there.
Yeah, just about every guide is going to assume we're working on AWS.
I just looked on my own bookshelf. I'm not necessarily saying these are the best books. They're the ones I've got. Terraform up and running. Nice little O'Reilly is always, always great. I've also got this book that called Terraform in Action. It's fatter than the O'Reilly book, so obviously it must have more stuff. But
honestly,
that's the two I've got. That's where I learned.
Yeah, for me, I didn't know any Terraform when I started this project, and honestly, I just learned Terraform by trying to do stuff, and then it all started making sense. It's like those old school adventure games. As you move to that square, everything around it becomes brightens up. That's basically how I learned Terraform.
Yeah, I mean, the way I
trying
learned
a few things. Yeah.
Same. I would just say that you go and find some examples out there, use those examples, and then kind of like you use Cisco config or a Juniper config, you got to go and find somebody that's kind of done something similar, and then you can take that and kind of grow from there. Same kind of thing with Terraform, right? Take something that somebody's already done. There's a lot of GitHub out there that you can find Terraform configs in, and then find something that looks pretty close, and then you can take it from there.
Cool. Well, Jeff, you got any last thoughts? Any last questions?
No, I'm very grateful for, thank you for the opportunity to learn new things. And I think our viewers should be interested in this. It's not kind of very new technology, right? Terraform been around for probably 10 years or so, but it looks beautiful and simple and in line with modern CI/CD practices. So just go and do it.
I think that's the bottom line.
Somebody should have that as a slogan.
Yeah, just do it.
Chris, Raj, and my brain just went blank. Anyway, guys, thanks for. I was going to say something and I don't remember what it was, but Chris, Raj, Bill, thanks so much for joining us. And this has been a terrific program. I always like the ones that run a little bit long because it says we've got a lot of good material in there and a lot of good stuff. And so thanks so much for joining us. This has been fun. It's been very informative.
All right, thanks, Jeff.
And for the audience, we will be back as soon as we can. I'd like to promise in 2 weeks from now, but we've been pretty iffy about our schedule, but we will be back just as soon as we can.
Absolutely. Thanks, everyone.
Thanks, everyone.